have a uniform square with weight 700 newtons. The square is held up by a piece of rope supplying tension T at a point A. You can see that here. And it's on the point of tilting at D, so it's pivoting around here. Given that the system is in equilibrium, what is the value of T? Now, the problem we've got now is on previous moment questions, all our bodies of mass were in the line of action. What I mean by that is all the forces are pointing in the direction that we want, and the pivot points are clear. In this one, it's not quite the case. So first thing we need to do is identify the centre of mass of the square. Notice it says uniform. What does that mean? Well, the weight is evenly distributed within the square, so its centre of mass is right in the middle. Okay. Next, we need to think about clockwise moments and anti-clockwise moments. Well, what will we have clockwise? Well, this tension here from the rope will produce a clockwise movement if we're pivoting around here, and also some component of the weight, so this little arrow here, will produce a clockwise movement as well. So first, let's think about what component of the weight. Well, it's going to be 700, and then it's going to be sine 15, okay, because we're taking this little arrow here. So sine 15, and then we need the perpendicular distance on which that acts. So that's going to be 0.25, isn't it? Yeah, so if you imagine that's going to there, it's half this square, so that's 0.25 meters. Notice the question gives it in centimeters, but I want SI units, so I'm using meters. Half of 50 centimeters is 25 centimeters, which is 0.25 meters. Okay, then we also have some component of the tension here. And in this case, it's relatively simple. We just need to work out the perpendicular distance. So if we went along here and along here, that's 50 centimeters, isn't it? Because you've done half of the height and then half of the width. Because it's a square, that's just the whole height or the whole width, which is 50 centimeters. So 0.5 meters. So we're going to have plus 0.5, and I'm just going to say T for now because we don't know the value of that. Okay, so that's all the anti-clockwise ones. That's all the clockwise ones. Let's consider anti-clockwise. So, what are we going to have anti-clockwise? Well, it's just some component of the weight. And I'm sure you can guess from other moments problems, if this one's 700 sine 15, this one's going to be 700 cos 15. Okay, because we're taking this little arrow here. Then, again, we have to times by the perpendicular distance, so we're timesing by 0.25 again. And now we have two equations in one variable, the t here. Okay, so these should be equal. Why should they be equal? Well, the system is in equilibrium, so it's on the point of tilting, but it isn't quite tilting, so these two are just equal to each other. So we'll have 700 sine 15 times 0.25 plus 0.5t equals 700 cos 15 times 0.25, and you've got a linear equation to solve here. So if we solve this, we'll get t equals 247.5 newtons.